Hello. This short video presentation is a continuation of yesterday's introduction to imaginary numbers. We're going to both simplify radicals today and perform some operations. So let's look at the square root of negative 32. We remember from yesterday the square root of negative 1 is I. We can write this as the square root of negative 1, the square root of 32, and the square root of negative 1 is I, and the square root of 32 is 4 radical 2, and this would be written as 4i square root of 2. The I always comes after the whole part here, the integer part, and the radical is always at the end. Nothing more. You know how to simplify the square root, and the negative just means it's I. All right, adding. First of all, we have what is called complex numbers. Complex numbers. And there's two parts to the complex number. There's a whole part, or a rational part, and there is the imaginary part. All right? So 2 plus 3i. All right? These are called complex numbers. We're going to be adding, subtracting, and multiplying them. So usually your problems will be written like this: 2 plus 3i plus 5 minus 2i. Basically, what you're doing is looking for like terms. We add the rational part. 2 plus 5 is 7. And then we add the imaginary part. 3i minus 2i, because it's negative, is just 1i. I. That's it. Super simple. If I have 4 plus 3i minus, subtracting now, 6 minus 2i, then we do 4 minus 6, negative 2, and then 3 minus negative 2. This is where you guys make mistakes. 3 minus negative 2 is plus positive 2. Be very careful. So we have plus 5i. Multiplication is very simple also. So if I have 2i times 3i, we just multiply. 2 times 3 is 6. I times I is I squared. And remember from yesterday, I squared is negative 1. It becomes a negative 6. I should note that when we multiply radicals, the square root of negative 8 times the square root of negative 6, we have to bring these negative numbers out, and we have I square root of 8 times I square root of 6, which is I squared square root of 48. And when we simplify the square root of 48, we get 4 square root of 3. And I squared is negative 1. So it becomes a negative. If we multiply binomials, 2 plus 3i times 3 minus 2i, we just do binomial multiplication. 2 times 3 is 6, minus 2 times 2i is 4i. 3i times 3 is plus 9i. And 3i, I don't know why that happens. 3i times 2i, it's a minus 6i squared. Combining our like terms, we have 5i. And it's minus 6 times negative 1, or positive 6, and we get 12 plus 5i. And lastly, we're going to look at division. We are not allowed to have a imaginary unit in the denominator. So if I have 2 plus 3i over 4 minus I, we do what we did with radicals. We multiply by the conjugate. Remember the conjugate of the denominator. Conjugate is this number, but we change this and only this, the operation, from plus to minus or minus to plus. 4 plus I, 4 plus I. This is exactly the same as when we did our multiplication, or simplifying with radicals. So now I do binomial multiplication on top. 2 times 4, it's an I, is 8. 2 times I is 2i. 3 times 4, 12i, plus 3i squared, over 4 times 4 is 16, plus 4i, minus 4i, and minus I squared. These cancel, as they always should, and we get 8 plus 14i, and I squared is negative 1, so that becomes a minus 3 over 16, and minus negative 1 is plus 1. We end up with 5 plus 14i. My tablet has a life of its own today. 5 plus 14i over 17. And that's our division. That's all there is to it. It's all pretty basic. No really bizarre new thing. The one thing I would caution you on is this right here, because our inclination is always to multiply first. No, bring out the I, and then multiply. Okay, have a great day, and I'll talk to you tomorrow.